This apparatus here helps us to visualize the magnetic field around a bar magnet. As you can see here, the compasses are pointing in random directions. Some of them are pointing in the direction of the Earth's magnetic field. But when I introduce a bar magnet over here, you can see the magnetic field around the bar magnet pretty nicely. The poles are stronger, right? So the magnetic field lines go away from the north and towards the south. All right, so you can see this three-dimensionally. Let me add this panel in, and it will be a complete three-dimensional picture of the magnetic field around a bar magnet. Now, if we want to draw the magnetic field around a bar magnet two-dimensionally, then we can do that with a magnet and a plotting compass. Let's try to do this. I have already drawn an outline around the bar magnet, all right? And you can see from here that the tail of the arrow is pointing towards this pole. So we know that this pole is a north pole. Some magnets have an indication, right? In this case, a dot here, to tell us that it is the north pole. So the arrow itself is a magnet, the tail being a south pole and the tip being a north pole. So it points away from the north pole of the bar magnet. So what do we need to do to draw the magnetic field around the bar magnet? We can start with one end of it, right? Let's draw a dot over here. And we move the tail of the compass to face that dot. And then we draw another dot at the tip of this compass needle. We continue doing this until we reach the other end. And we can join the dots together. At this point, let's draw the arrows, and we know that the North Pole is on the left side, on this side, and this side is the South Pole. So the compass needle will always be pointing away from the north and towards the south, away from the north and towards the south. So the arrows will likewise be pointing away from the north and towards the south. And there we have it, a two-dimensional drawing of the magnetic field around the bar magnet.